Hi guys, I welcome you all to the ninth video of Module 5, and here we are going to go ahead and generate a dummy dataset for our training purpose. The analogy that we're going to use over here would be to compare the size with respect to the brightness, and then we are going to input some of these libraries and then generate this kind of training data with the help of a random module that we'll be seeing of NumPy. And on top of that, you will also be spending some time in understanding this kind of dataset. So let's get started. Alright guys, so the coding process starts over here. It's going to be super fun. Just make sure to code along with me. So the libraries that we'll be requiring over here are the two, one for the visualization purpose and one to store the data in the array and deal with the array. So you must have realized what type of libraries we are using. For the visualization purpose, we are going to use this matplotlib's pyplot module and numpy for dealing with the arrays. So import matplotlib.pyplot as plt and also import numpy as np. So the library part is settled. After this, we are going to focus on the part where we are going to generate a random dataset for my xtrain and ytrain. Now you must be wondering, what is this xtrain and ytrain and why are we even using a random dataset? Well, I already explained you the reason in the previous video, but for those who have yet not understood this, trust me, in this video, you will have your answer that why do we require a random dataset in this case to understand what's happening internally. But for now, there is one important thing that I need to point out over here is that while you are training your machine learning algorithm, you also need to check if it's performing well on a test dataset. So generally, you will require at least two types of dataset whenever you are dealing with this kind of machine learning. One type of data is called as training data, and the other one is used for the testing purpose. So using this training data, you are going to train your model. And this testing data is actually the data created for the same type of environment. It's not any type of random data. This data is similar to how this data set looks like, but it's not having the same values. Rather, this data is created from that same environment to test, all right? And therefore, this will be used for the testing purpose. Now, in this training, what's really happening? This is the part where your model is going to learn about your weights and bias. This is the part where you will use that trained weights and bias to make the predictions. Use trained weights and bias to make predictions. And if these predictions are working like a charm, it means the training is successful. It's just like how you are getting trained right now by writing each and every code along with me over here. And then in the quiz, you will be doing some things here and there. And that's your testing part. You are going to be tested on the same type of concepts that I'm teaching you right now. But it won't be the exact same thing that I'm giving you over here. It might be something different. So that becomes your testing dataset. And remember, in your training dataset and the testing dataset, it's always better if it's not exactly the same. Because if it's exactly the same, there is no purpose of it's like, you're trying to cheat over here. I'm already telling you in your training that this is the type of questions you will be getting in your testing. So it's not good, right? So make sure that you are always having this training data and testing data which are different from each other. At the same time, they are taken from the same environment. It's not like, this is completely a different type of data. This is a different type of data. That should not be there. So yes, guys, I hope you have now understood that why I have written xtrain and ytrain over here. So now what is this xtrain in our analogy? This xtrain is the brightness of a star. And then what is this ytrain? This ytrain is the predictions, or I should say ytrain in itself is the actual data for the star size. Based on this input of your brightness, what will be the output of your star size? And this is what our model needs to predict. All right. So yes, this is the description that we are having for this generation of this fake dataset or the dummy dataset, where I'm going to generate my brightness values. There are a total of 100 brightness values. And then there is only one column, which means there is only one variable, which is brightness. We don't have any other variables. And this is not really case when you deal with a real dataset. You will have a lot of parameters to think about, a lot of input variables that's going to be affecting the output. But for now, because it's a demonstration purpose, I have just kept only one variable, that is brightness. In the upcoming module, you will be seeing that we are also using absolute value of that star, luminosity of that star, then temperature, radius, all of these things will be used to make some kind of predictions. But yes, right now, just understand the process. All right. So there are total of 100 different stars with different brightness, and all of this brightness are random values between 0 to 1, which we are then scaling it up by multiplying it with 3. So this is something that we are going to deal with. So how can we get a random numbers between 0 to 1? Let's try to figure that out. So np.random.rand is going to give me values in between 0 to 1. That's for sure. As you can see over here, I can run it multiple times and you will see that the values will always be in between 0 to 1. Now, if I want this for 100 times for one column, I need to give in 100 comma 1. So now it's going to give me 100 values in between 0 to 1 and for one column, which is acting like a brightness. Now I also want to scale it up by 3 times. So I'm going to multiply it by 3, and this is the data that I'm going to have. But now if you notice, I'll run this again. You can see that these numbers are getting changed every time. Currently it's starting from 0.7759, then it is 2.9.29 something. Now just if I rerun it, it won't be the same numbers over here. So I'm going to run it again, and you can again clearly see that these values have changed. So how do I make sure that whatever results I'll be getting, you get exactly the same results? It is only possible after using a seed value. That seed value is going to generate the same type of randomness as I had explained in our, I guess, fourth module, where I was talking about random numbers with the help of NumPy. So I'm going to set this random.seed, and the value that is asked for our use case over here is given as, I guess, 100, right? So I just choose that 100 over here and see what happens now. Now you will realize that these values will not change. You can just keep eyes on the first few values. For example, now if I run this code, you can see that the same type of output has been generated. And yes, because of this, you will be able to replicate the same type of output that you will be seeing over here in my particular screen over here. All right. So this is something that we want to generate, and I'll just copy this part and come down and paste it. I'm going to generate a seed value of 100. After that, this is my x train. So I'll just say that this is my x train equal to this. And now comes y train. This is the important part, guys. This is the important part. How we are generating the y train data. Now we know that because we are dealing with a linear regression, the output is going to be that straight line. So this y train needs to be in that straight line as well. So over here we are having 9 plus 2 times x train. So if I show that to you over here, it's 2 times x train plus 9. Let's not think about noise for a while. Let's just think about this part. Right. So what I have done over here is I'll just keep this as uppercase. And yes, so I have generated first of all the brightness values. And now using those brightness values, I'll be getting some kind of an output. Now, what type of output I am going to generate? I'm going to show you with the help of this kind of a scatter plot. Now, how do you generate a scatter plot? I use plt.scatter. I give in what is the x values I want to plot, then what are the y values I want to plot. Along with that, I can also give some kind of a color. For example, let's say I'm giving royal blue. All right. And after this, I'm going to do plt.show. Let's see how does it look like. Obviously it's going to be like a straight line, right? So let's just wait until we get this output. Yes, this is the type of output that we generate over here, right? Now it's completely a straight line over here, guys, completely straight line. And when x is equal to 0 over here, you can see that the output is 9. So this is your y-intercept, and this is what we see over here, that yes, y-intercept indeed is a 9. Now the gradient of this particular line is 2, because you can see that there is a 2 over here. Now in machine learning, what's actually going to happen is we are going to create a y prediction equation. Because we are having only one x, only one variable, I'll have only one weight with respect to that x, and then yes, one bias value. So this is the prediction equation for this type of data that we are dealing with. Now this will also be a straight line, but now just to create some kind of excitement over here, I am going to add some kind of noise. Now what is that noise over here? This noise is again some random numbers between 0 to 1 of the same shape, 100 comma 1. Now this is going to ensure that either any number in between 0 to 1, I'm either going to add it apart, or maybe it's going to be where it was on the first place. Like it might be on the straight line, or it might get adjusted depending on the random numbers that we are going to add to this Y tree. So see what happens if I'm going to add that noise. That noise is nothing but the same part that you are seeing over here. I'll copy that thing, I'll paste it over here, and now I'm going to run this code. Now you can see that this bunch of data that we have got is completely, not completely, but it's not in a straight line. So it's a little bit of way through which, like, we are trying to mimic a true type of data set where it's not always going to be the way you want it to be. Okay, you can never have that straight line in reality. If it was that simple, life will be so easy, right? Your real data set will have some random data points here and there. From that, we try to do some kind of analysis, and if our analysis is showing us that there is a strong positive correlation like this, like a straight line, you can surely go ahead and choose linear regression to have a line of best fit. And this is exactly what you will be getting by the end of this particular module. So I hope that this part is clear, that how we have generated this X train and Y train, and now what is the reason that I have generated this in a dummy way, okay, or in a fake way. So the reason behind that is I want you to understand that this 2 is the value for that weight that I was talking about, and this 9 is the value for the bias. But remember that because we have added some kind of a noise to it, and this noise is lying in between either 0 to 1, right? So maybe around zero point 0.5 you can say, and on an average it's the value that it's going to take. So what I want you all to realize is that at the end of your training, the weight value should be somewhere close to 2, and the value of bias should be somewhere close to, like, roughly 9.5. This is something that we already know over here because we are trying to test how the linear regression is going to work. So yes guys, this is how it's going to work. Your weight values will be closer to 2. The bias values, considering this kind of a noise in the data, will be close to somewhere around 9.5. I hope now you understand why did we choose this type of dummy data set. In reality, you don't have to, like, create this kind of a line, because if you already knew this type of equation, then what is the purpose of training? You are going to train this kind of machine learning algorithm because on the first place you don't know this type of relation, and therefore we train this kind of machine learning algorithms to get these values without explicitly coding it for different type of data sets. Now currently I've given this kind of data, right? I can surely go ahead and change this kind of random seed values and see how the output looks like in that particular case, right? So yes guys, this is something that I'm trying to explain over here, that in this type of generation of the random data set, it's only done because you understand that what your linear regression has to learn over here, what weight and what bias value it has to learn. In reality, this values will not be there. You will simply have a tabular data with bunch of columns over there and bunch of rows over there. Your task will be to implement some of the machine learning algorithms that you think will be working best with that data, and then get this kind of, like, y-intercept, or sorry, this is the y-intercept and this is the gradient. In this case, because we are having only one x data point, that's the reason why we are having only one weight value, and bias value will always be 1. So yes, that's about how you can generate your own training data to understand that how your linear regression is going to work. Still, if you're having any type of doubts, make sure that you are clearing before you are moving any further from this point. It's super duper important. That's why I've just repeated a few lines of code so that it gets into your brain, like, for sure that you know what's really happening. So yes, I hope that you've got this idea of what is the purpose of creating this kind of dummy data. And let's just go ahead and visualize this in the next video, that how is it going to look like.